Hi, welcome to a brand new SimplyMaya tutorial series. In this series we'll be discussing techniques for hard surface modeling, and we'll be using this image you see in front of us as sort of a base point for our reference. Now, fans of Doctor Who may recognize this as a Dalek assault claw, and for the rest of you I'll include some reference of what it looks like on the TV show so you can see we've got it pretty spot on when we finish modeling it. Now, we picked this object because it requires a variety of techniques to complete. We've got some very curved hard surfaces. We've got some, sort of chamfered surfaces here that have to remain with very hard edge lines. We've got these wavy pipes. We've got, this detailing on the claws. It's actually not the simplest thing to put together when you start to look at it. And as I said, it requires a variety of different techniques within Maya. We'll be using some NURBs, some curves, some polys, and then making sure we have one nice poly model at the end of it. So if I just flick off that reference for a minute, you can see one I created a bit earlier, and this is basically what we're going to be doing. So before we start to do anything, I'm going to pop open a new scene. I'm going to assign a new project, so I'll go to project window and hit new, and my new project will just be claw tutorial v1. Obviously you can give it any name you want. When I hit accept now, this project will be created in this location, so it will actually create a directory for it, and underneath it will put all of these directories in a proper hierarchical structure. So I hit accept, and I'll just nip into my network drive and show you what happened. So basically it created a directory for us, as I said, called claw tutorial v1, and underneath it put all the directories necessary by Maya. Now this is an important first step to keeping your work organized, and it's quite nice to work this way as well. When you go to open scene, it opens in the right place, it saves in the right place. If you're looking for an image, it'll open in the right place, and it's much faster to set a project before you start. So let's get on with some modeling, and before we do that we're going to require some sort of reference image to work from. Now there's tons of blueprints on this particular model on the internet. I've actually taken the liberty of creating my own, but if you want to search for other blueprints, please go ahead. And there, I've got a image here also of it, what it looked like on the TV show. So basically I'm going to start by opening this image, and then I'll open this reference image. Now, as we're working in Maya 2015, you can just go to create free image plane, and that will do it for you. Now the nice thing about this is when I load in an image, it will automatically scale the image plane to the right aspect ratio. So if you've done this before on perhaps a poly plane, you'll know that you have to scale it up yourself. This one, it's actually quite nice. I've got some reference here in the images folder. So if I just go on to reference blueprint and click open, you'll see that automatically scaled that to aspect for me. So I can then make it bigger or smaller depending on my needs. In this case, this will be fine. Now I wouldn't normally model to scale, but because we can always scale this up afterwards, it's not terribly important in this instance. Okay, so that brings our image plane in. Now I'm just going to bring in a reference image to use, and I'll actually do this with a poly plane for anyone that might be watching on an older version of Maya. So basically it's the same thing. I'm just bringing in a plane. I'm going to rotate it. I'll press J to lock its rotation, in this case in 15-degree increments, and that gives me a plane. I'll then go up to the channel box and just make the subdivisions 1 and 1. So now I've got that, I'll have to assign a new material to it. Click Lambert, go over here and just load in a texture. Okay, so in this case I think I'll use this one. There we go. I'll hit open, and I'm not seeing that, so push 6 and I'm still not seeing it, so I probably have default material turned on. Okay, you'll see the difference with this one is it didn't automatically scale it into the correct proportion for us. So you'll need to get this to the correct proportion. A quick way to do that is to go under here, hit view, and I can see this is 600 by 430. So I'll just go in again to the channel box and go 64, sorry, that was 600, so 60 by 43. Puts it in the correct aspect ratio, and then I can use the universal scale to scale it from there. To be honest, normally I would put this type of reference on a second monitor, but then you won't be able to see it, so I'm going to just leave it here for the moment. Alright, so that brings in some photo reference and an actual blueprint. Now, one of the nice things about this new image plane system is I can't actually select it. So when I'm modeling and using it as a background, I won't accidentally keep clicking it. The same cannot be said, however, for this polyplane. So I'm just going to go again to the layer editor channel box, go to display layers, click new display layer, and switch this to R, which means reference, which now means it's unselectable. Okay, so depending on your version of Maya will depend on how you'll need to do this. I'll also be using the modeling toolkit with this, which is now available in Maya 2015 and above. And obviously, if you're in the normal version, you'll have to use the equivalent Maya tool. So for multi-cut, you'd use insert edge loop, or the split poly tool. Bridge and bevel are about the same, although I would say the new tools in Maya 2015, the bevel especially, works quite a bit better. Alright, so now we've got our basic scene set up. Let's create some of the primary components that we're going to need to make this project happen. So I'm going to come in here to the front view, and the first thing I'm going to do is get lined up on this. Now, this image plane for me, let me just see, is the wrong way around. That's better. It just, again, it depends. I would rather model out towards this way. This is the back of the object for me, so really you can do it anyway. It's just what you're comfortable with. Alright, so I'm going to start by just bringing in some of the basic elements. So let's start with the sphere here, and let's move this approximately into place. Okay, and you'll see I can't actually see the sphere. So if I take my image plane here, and it's actually sitting in front of the object, and just move it to behind the object. There we go. Now I can come in and make the sphere a little larger and get it into place. Okay, so that's that. Now the reason I wanted to get a couple of the basic elements in is because with this sphere, if we were to render this now, you'd see it's actually not that spherical. It's quite jagged. So I can hit 3 on the keyboard, which will smooth this. Now, this is fine for something like a sphere, but when you're doing a hard surface object and you want a very sort of harsh chamfer, you can't really smooth. It is possible, but you know, if you want that crisp edge, which I'll demonstrate to you now. So I'm going to bring in a standard cylinder, and I'm going to turn on X-ray so I can see the components behind one another. There we go. And I'll show you what I mean now. So I'll just rotate this thing, and I'll get it roughly in the shape of our back component here. Okay, and let's bring that in and up a bit and just get it roughly into shape. Okay, so there's one cylinder. Now let's bring in another one, because I'll be able to demonstrate with the both of them, and again get this roughly into shape. Okay, now let's see what happens when one of these is smoothed and one is not. So I'm going to disappear into the viewport here. Okay. So, and I'm just going to check my viewport 2 settings to make sure I have anti-aliasing turned on. I do not. So let's turn that on. That'll help us get a better look, and also I'll flick on the ambient occlusion. Alright, so as you can see, this is fairly jagged, as is this, because these are identical objects. So if I hit 3 on the keyboard to smooth this, it'll completely collapse in on itself. So the first thing we'd need to do is add some edge loops around here and here, just to make sure that that doesn't happen. So I'm going to go to the modeling toolkit, multi-cut, hold control, and I'm going to put an edge loop close to here, and then I'm going to put another edge loop close to here. Now when I hit 3, this should collapse less on itself, and we've even got a bit of a beveled edge. But it's not a hard bevel. You know, this is not milled machine kind of cut steel anymore. So, you know, I can make this a bit better by adding another enforcing edge loop here and another enforcing edge loop here, and then I get a bit of a better bevel, and it's quite acceptable for a lot of things. But if you're wanting a very hard chamfered cut, we need to start with this cylinder, and because I can't smooth it, I'll get this kind of cut if I smooth it. I'm going to need to add more geometry right from the start. So I'm going to go up to the channel box, select the inputs for the poly cylinder, and make the subdivision axis from 20 to say 80. And this will add a lot more polygons right from the start. I can then simply grab this edge and bevel it. So I'll use the modeling toolkit, hit bevel, and just use the mouse button to put a nice bevel on that. Okay, now you should be able to instantly see the differences between these two. This one looks like a very hard edged cylinder, and this one looks more smoothed. So if you're doing a hard surface model that requires these sort of really crisp edges, sometimes you have to start with more geometry. Now, if we take a look at how this works, this smoothed cylinder, is 140 faces, and this one is 320. But actually, this smooth cylinder at render time will be more. So if we put it back to the non-smooth view, which is 1 on the keyboard, and I actually do a mesh smooth, which is what Maya actually does when you hit 3 on the keyboard, and this will be 2 smoothing levels. So I'll go into the poly smooth face node and put the divisions to 2. So there you go, it's what we had before, but once we were a preview of what the smooth would look like, and now we have the actual smooth. So just to show you, this higher resolution object that we started with is 320 faces. This one that was smooth, that looked lower res, is actually 2080 faces. So don't be afraid to start with a bit more geometry. I know that there's always a tendency to go as low as possible and then smooth afterwards, which is perfect for organics. It's perfect for a lot of modeling. But if you absolutely need this hard chamfer and you need to work with a very hard surface, sometimes your best bet is to start with more geometry. Okay, so if we were creating a tube for this back piece here, I'd actually start with more geometry. So let's come in, and I'll just move this tube that we've got here up into the appropriate position, and I'm just going to bisect this with the sphere, and then I'll go to vertex, and I'll come back and I'll make this a little longer, and it may even need to be a bit bigger than that, so let's go up to about there. There we go. So this sphere is fine to smooth because we don't want any hard chamfered edges. This not so much. So as you can see, with that smooth one, kind of looks okay, but it isn't really what we are looking for. You know, this chamfer, it's all right from a distance. You know, you get away with this on most things, but I want a very, very hard edge, which means a single chamfer with a single line. Alright, so in the next part we'll get on and probably model quite a bit of this back piece. So I hope you found that somewhat interesting, and I will see you in the next part. Thanks for watching. Hi, welcome back. In the last part we finished up here, and we've just got our kind of high poly or high poly-ish cylinder here. So the first thing I want to do is get rid of this bevel that I've got, you know, as a demonstration purpose. So rather than making the whole thing again, because it was built with construction history on, I can just go in and take that bevel off. So if I click the object, go to the channel box, have a look under its inputs, you'll see a poly bevel. I can turn the fraction to 0 and the bevel will disappear. I can also then go in and edit, delete by type history, and this will put us back to a nice, clean, pristine object. Now the other thing I was going to look at was this reference image we're working on is not the best in the world because it's still showing the wireframe. So I took the liberty of creating a different reference image. So I've just got a reference image version 2 here that has no wireframe. Now obviously that reference image is going to be at a bit of a different size, but that's okay. I can just scale down the components I've made. It's not a good idea to do that when you're halfway through the process, of course. And now this one. So realistically, this reference image just makes it a little bit easier for us to see what's going on without all those blue lines in the way. Now, towards this, we can also tone down this reference a bit. If you've got a reference image with a very white background or a dark background, you can come in here, and in this case, then I can adjust the color gain to grey that out a little bit. I can also adjust the alpha gain to make it a little transparent, and that normally helps quite a bit when you're looking to line things up with the reference. I find this much easier to see now. Okay, so without any further mucking around, let's get on with the modelling of our cylinder. And the first part is this part that comes out here and is kind of split like so. So I'm going to use the multi-cut tool for this, but you can use the insert edge loop on an older version. So I'm going to go to multi-cut. I'm going to create the first edge loop here, as we'll need one, the second one here, and we'll need one here, and that's here and here, and basically I'm just putting an edge loop anywhere that I'd need to change this. So there, and I won't need an edge loop at the back because we can use a bevel for that. Alright, so let's create this portion here, which goes both up there and down there. So I'm going to go on to face mode, which you can do by selecting face mode on the multi-cut tool too. And I'm going to select both groups of these faces, and I'm just going to extrude them outwards. Now I've got too many faces there, I think. Let's just make sure I've got just these ones. And once again, extrude outwards. Okay. Now if you're finding your extrusions kind of all over the place, you can just hit reset settings, and that will bring it back to default. And then I'm going to use the left mouse button to drag it out to where it is on the reference. And to get this slope here, the reason why I cut this edge was because I could now go to edge mode, which on the multi-cut tool is just here. I can then press Q to get out of the multi-cut tool, double click this edge loop to select it, click R to scale it, and bring it back like so. And that way, if we go into the perspective view, I get something that looks like this, which, if we check the reference here, is pretty much what I'm after. Now the reference appears to be very hard edged, and ours does not appear to be very hard edged. I can't really see that nice hard edge there. So in order to fix that, I'll just double click that entire edge loop and hit bevel. Now I can either go to edit mesh edge bevel and do it there, or I can do it with the bevel tool here. But if I go back to object mode now, you'll see I've got what appears to be a harder edge. Now let's come in here, and if I look here, I'm just going to pull this edge out just a little bit proud of this, and then I'm going to bevel this edge as well. So select the edge, select bevel, and I want a very, very small bevel in there. Okay, this will also help us to get that, you know, much harder edge, you can see. Now we will go and harden the edges again in a minute, but just for now I just want to make sure that the basics of this are looking right in the viewport, and it's looking like crisp, hard, clean edges. Okay, so let's get on with the rest of it. Now we've got to cut into the actual cylinder here. So again, we would need to allow for that cut. Now I've put one edge loop in, I need another one. Let's put another one in, face mode, select these faces, and I'm still on the multi-cut tool. So if I let go now, it'll put another edge loop in there, which I don't want. So press Q to get out of the multi-cut tool, select downwards like so, and once again you can just do a extrusion downwards. So reset the extrusion, and let's extrude downwards so we've got a little lip. Okay, and then again I would go in and bevel the top edges of these, but we'll do the other bevels in a second. So Q for selection, select these faces, extrude in, down to there. Okay, now let's have a look at what we're looking like. Alright, we're looking pretty good. Now I seem to have accidentally at some point put another edge loop in here. So if you found you've done this, you can always just select the whole edge loop and don't press delete on the keyboard. If you simply press delete on the keyboard, what will happen is the vertex that are left over, so here there would be a vertex. If I just hit delete now, the vertex will stay. So what you have to do is press shift, right click, delete edge. and that will get rid of the edge and the vertex, so it doesn't leave any extraneous geometry behind. So now we're kind of looking like a pretty decent hard edge shape. So now it's just a case of going in and setting up those chamfers. And really the difference between a chamfer and a bevel is a chamfer will have one edge. I'll show you. So let's just go up to bevel. So we can do that by pressing the space bar, edit mesh, edge, bevel. And under the attribute editor now, the channel box, I will have our latest bevel, where I can turn the fraction down to say 0.1 or even lower, 0.05 in this case, and you'll see I've got a very small chamfer there. It's got, one face between it. Now that's a chamfer. If I were to put 2 segments in, that's more of a bevel. Okay, on most hard surface stuff I normally simply chamfer the surface. Now, if you're using the modeling toolkit, you can also, of course, select the edge around, and I've still got the multi-cut tool selected, so select the edge around, go to the modeling toolkit, bevel, and then control the bevel by just sliding the mouse backwards and forwards. Okay, so it depends how accurate you need to be. And once again, now I can just press G to repeat the last command, and it will give it the same bevel. So again, select the edge loop by double clicking, G, and there we go. And for the back, G, and I want a fairly big bevel on the back piece. So that's pretty much all our beveling in done, but still the surface could look a bit harder maybe in between. So there is a couple of ways to harden an edge. If you want it chamfered like so, then you can just chamfer it. If you want it hardened without putting a chamfer in, so in this case I don't really want a bevel in between these pieces, but I do want this edge to appear a lot crisper than it does. So how this is achieved is through the normals. I'll just select the whole edge, go to normals, harden edge, and you'll see that immediately hardens that whole thing up. If we go back to object view, you can see now this is a much harder edge, and we can come in and actually see where those hard edges are on our model by going up to display, polygons, and then there'll be a hard edges here. There we go, hard edges. And you'll see what happens is our hard edges are then highlighted in this darker, or sort of lighter in this case, green. So there's a hard edge there, that's good. We've got hard edges pretty much everywhere we would want them. Now, because I want this to look like very sort of cut steel, I'm actually going to harden these 2 edges up as well. So once again, spacebar, normals, harden edge. There we go. And now it's looking much more hard-edged as a model. So if we hadn't have started with this high-res or slightly higher-res geometry, it would have been difficult to get these kind of small, subtle chamfers in. And you can make them a bit bigger if you want them to appear a bit predominant. But what they'll realistically do at render time, these will catch the light with a very hard edge, which will make your kind of shiny metallic or even dull metallic objects look very, very solid. Now, if we smooth this, you'd end up with something that looked more like that, which is obviously not what we want at all. So, sometimes best to start unsmooth. We just check that we've got everything we need, and I'll disappear back into this view and check that it matches the reference. If it doesn't, of course, you can do some adjustments. Now, the bevel that I had on the reference object was obviously bigger, and you can then just adjust that in the bevel settings. This was a bit this way, so sometimes you'll need to come in and do some tweaks, and this matches, so that matches. Okay, now the last thing was this component here, which was actually added in afterwards. So in order to get that component, all I'm going to do is take a box, standard poly box, and then we'll get it into position, get it on the reference kind of lined up there. Oops, and I've selected the wrong object. You can use the F keys to swap in between the different modes, vertex, face, component, whatnot. The reason I am not is because they're also assigned as hotkeys for my recording software here. But I'd advise you to maybe get into the habit of using those keys, F8, F9, oops, and actually just go to object mode, because it makes the selection quite a bit quicker. Okay, so I should have a box that's about the right size there. And we'll scale it in. And I know this is in the exact center of my object where I want it, because I haven't moved our objects here. I haven't moved anything in the z-axis. So everything that starts out will always be in the center, or at least the center of the grid on the y-axis. Sorry. Okay, so there we go. There's that one. And now we would need to bevel this in. So again, edge, and you can just select the edges you need to bevel all at once. For something like this, hit, better off going edit mesh, bevel, and there's a bevel around that object. Just gives it that nice highlight. We can check to see if those beveled edges have come in as hard edges, which they should have done, but you know, never hurts to check. Let's just go to display, polygons, hard edges, and there we go. You can see those are all hard edges. Okay, so that's how you create a very hard-edged object with these nice chamfered bevels. Alright, so I'll be back in the next part when we look at creating our first tubes, which is a completely different technique altogether. So I hope you stay with me for that, and thank you very much for watching. Hi, welcome back. In the last part we got on with the modelling of our back handle here, so this portion, and in this part I want to talk about these tubes, because these are quite fun to make and not as difficult as you might imagine if you've never done them before. So I'm going to actually make these tubes with a curve first of all, and then I'm going to extrude a NURB surface along it and finally convert it to a polygon. This has certain advantages that we'll cover as we go along. So first thing, we need to create some sort of NURBS curve. So in this case I'm going to use a Bezier curve. It works a little like the pen tool in Photoshop. Now it really wouldn't matter if you use the EP or CV curves, but I like the Bezier curve tool. I like the way it works. So it works by putting down points, and then you can bend those points afterwards. Actually, you can bend them on the way through. I find it easier to bend them afterwards, but basically if you've used the pen tool in Photoshop, you'll pretty much get a grip on this. So we start by left mouse clicking to put down the first point, and then we want the second point, the third point, and the fourth point. So this has given us something that now doesn't look much like a curve. But if we go in and hold Control and left shift, and then come over the dot, hold the mouse button down, you'll see it gives me a curve handle. Just, you know, very similar to the pen tool in Photoshop. So I can now just go around and curve these out until they kind of match the center of my curve point here. And if you just grab the point by itself, you can of course just move it around. You can also grab just one end of the handle, but in order to move it independently, if you hold Control down and grab one end, you can then move it independently. So it gives you a great deal of control over your curve. And for a simple curve like this, you know, the EP or CV curve tools will be fine, but you know, it doesn't hurt to have a bit more of a degree of control. And there we go. So once you finish your curve, press enter. Now if you're editing a Bezier curve and you press enter and you want those control handles back, if you just go to Control Vertex, this is not really going to give you the same amount of control. I mean, you can do it with a Control Vertex, but now I can't edit one side of this and it's not quite the same. So if you just select the curve itself before you select its Control Vertex and just go back up to Create Bezier Curve, this will bring in the original controls for the Bezier curve. So now I can click on this point, grab this one with control, and I've got all that editing capacity back. So if you are working with one of these curves, you can just get back to it by going back to its create Bezier curve, and it will give you all the original kind of curve handles. So now I've got the curve that's in approximately the right shape. What we need is to get this tube along it, and to do that I'm going to use a NURBS curve, just a standard NURBS circle here, and that will have been created down there, and I'll bring this into approximately the right position, and then I'm going to rotate it. I'm going to hold J to stagger that rotation. There we go. And I'm going to move this to the start of my curve. Now if I want it in the exact center of my curve, which this will probably be pretty close, but let's say I wanted to make doubly sure, I can select my circle here, select snap to curves, and then come in and grab the snapping point. Oops, I've snapped to a curve over there now. Come here, you. And I'm just going to snap this onto the curve, which can be sometimes a pain in the backside. There we go. So that's snapped it to the curve. I can't pull it any further back, and that's now right at the center of the curve. So yeah, I can just show you that that's, you know, spot on. All right. So make sure you untick your snap to curves, and now we need this circle to, let's make sure it's about the same size as this tube. It is. So we're going to take this circle and extrude it along this path. So select the circle, select the, in this case, the Bezier curve, and go to Surfaces, Extrude. Okay, and that extrudes out our circle for us. So it's in approximately the same shape. If I press 3 to smooth it, as I would smooth this, you'll see that we're in approximately the right shape. Now you'll also notice that mine's extruded outwards as a polygon. So if I just delete that extrusion and select these again, I'll be able to show you a little bit about the extrusion menu. So Surfaces, Extrude, and I'll just reset that to its default. So by default it will extrude an output geometry of a NURBS curve. There you go. Oh, sorry, of a NURBS surface. So we can change that later on. You'll also notice that this is not in particularly a smooth extrusion. So we can select the curve, go to Edit Curves, and first I'll convert this to a standard curve. So modify, convert, Bezier curve to NURBS curve. Okay, and then I'm going to rebuild this curve so it has more control vertex, because if we look right now it has about 10, so let's give it some more to work with, and then we can actually smooth it. So edit curves, and let's rebuild the curve. Let's give it, say, 12 spans, rebuild, and that's given us a much more curved shape. We don't have those jagged edges anymore. So then I can go to curve smooth even. Probably don't need to smooth this one, but if you want to, you could smooth that curve out a bit. For me, not necessary. Okay, so select this one, and let's extrude straight to a polygon. So Surfaces, and let's go to Extrude, pop open the menu. So Output Geometry, Polygons, and I want quadded output geometry, and I want to extrude via, let's just try the standard fit to start with. Now this normally isn't the best one, but let's have a look. And in this case, the standard fit, I can see up here we've got some geometry that's not particularly pretty, but we could probably fix that. But you know, if you don't have to, let's go to Extrude once again and try a different fit. So Surfaces, Extrude, and this time I'll just output to control points and extrude, and that's even worse. So that's not great for us. Nope. Okay, and you notice the surface of that was black, and in fact if I bring that back I'll be able to explain why. On the surface of this object, all of the faces have normals that point one way or another. You've seen how we've manipulated them to create harder edges. Well, if I look inside this tube, you'll see it's lit properly, and outside it's not. This is because all these normals are pointing inwards, and if you have your lighting turned on to two-sided lighting, you want to turn that off. It becomes easier to model with two-sided lighting turn off. It's very obvious when you've got normals that point the wrong way. So you just go normals, reverse, and you're back to where you should be. Anyway, let's find a nice way of doing this extrusion. So surfaces, extrude, and whenever you're extruding along a curve like this, or indeed whenever you're converting NURBS to polygons, you often have to play around with the options of the conversion to polys just to get the look you're going for. So a good one that normally works is to just go to count and quads, and this will say how many polygons we want created. So let's start off with less and try this. Okay, that will actually do it for us. When I smooth that now, nice and smooth, and because we're not putting hard edges on it, it's pretty much perfect. Now if we look at that compared to the reference, ours is a little bit thinner on the tubing, so that's a fairly easy fix. We just make our circle here a little bit bigger to start off with, and then just once again surfaces, extrude, and now we're more in line with the tube on the reference. You can of course now go into the vertex and grab a few verts and start pulling the tube. Whoops, let's grab a few of these and start pulling the tube exactly into shape as it was on the reference. Oops, missed the vertex. There we go. So as you can see, you can match this up to the reference pretty accurately. I'm not going to spend a lot of time doing that because, you know, I think the shape of this particular tubing is absolutely fine the way it is. So we managed to create a fairly low poly tube there in exactly the shape we wanted it in. So now we need to create these little kind of torus pieces, these pieces that go along, and it would be a complete pain in the backside to have to come up, create a polygon, say torus we'll use for this, and you know, I'd need to get it into the correct position for a start, and then I'd need to alter that position all the way along the tube, duplicate it up, and you know, it's going to be a bit of a pain. So we've got a trick for this. Get your torus into the right shape, and I'm just going to rotate mine 90 degrees upwards again, and I'll make sure it's about the right size, so we know we want it to sort of look like so. So let's come in, and if I go under its channel box torus, I can change its radius to say 0.1, and that will create a much thinner torus. And you know, I want it to go along this pipe. So first things first, I'm going to snap it to the end of this curve so it starts in the same place as this circle. So I'm just going to go up here and hit snap to curves, and to make this easier I'm going to select the curve and the torus and go up to show, isolate selected, view selected. This will make it, whoops, this will make it very easy to snap this to the curve. Okay, and that's snapped to the end of the curve. I couldn't move it any further. I know it's perfectly in the center of the curve, so then I can just go up to isolate selected, view selected, and we'll know that that's right in the middle of where this curve is. Now, we looked at, before I go any further into showing you how to replicate this up along here, I just wanted to say one other thing. We looked at changing the shape of this by quickly pulling the vertices. We can also select the curve itself, go to the curves control vertex and edit those. Whoops, they're on snap to curve. That will also change the shape of the polygon pipe as well. Very handy. Okay, just so you know, you don't have to then simply use the vertex on the poly object to manipulate it. You can use the curve. Alright, so now we've got this torus here, and we want to basically duplicate it up along here without going through all that trouble of kind of moving it about and duplicating it manually. So the thing to do is create a motion path that this torus will follow. So I need to select the curve itself, select the torus. I then need to come up and go to animate. So I'm going to use the marking menu, so just spacebar, animate, motion path, attach to motion path. But I don't want it to go for 120 frames. I don't want to be creating 120 objects. So I should be able to input a start time and an end time and just say 12. I want 12 of these things. I think there's 10 on the original. We can actually check it in the reference. Yeah, there's 10 on the original. So I'm going to do 12 because one will be at this end and one will be at that end. So I'll probably have the required 10 along. So I'm going to just hit attach. Okay, and you'll see that's kind of straightened up a bit. It's attached to the motion path. I'll change my frame range down here to 12, and you'll see that that's created 12 copies of this object all the way along our curve. Now they're not perfectly placed in some instances, and some of that would be to do with us moving those vertices before we did this. But you know, they're pretty close. It makes it a lot easier to edit. But now I need to tell Maya that I like it to create these as geometry and not just this animation. So that's not too difficult either. I can go to animate again and create an animation snapshot. So let's just check out the options for this. Start frame, end frame, okay, 12, snapshot. And there you go. You'll see I've just created 12 of these all the way along the pipe. Okay, so I don't actually need this original object anymore. Now I can come up and I can smooth these, which will make them shrink a bit. And then any final placement that needs to be done can now be done by hand. But, and we're going to have to center the pivot, so modify center pivot. Any final small kind of interposition tweaks that can be done very easily. Okay, as opposed to trying to do all that by hand, we now have a lot less work to do. And this one might need to be a little smaller because our pipe is not completely uniform. So there you go, basically. Quite simple if you use a curve. And you know, all you have to remember for this is to get the geometry out. We extruded along the curve, and then to get these multiple kind of rings, we just used a motion path to attach a piece of geometry to, and then from that motion path we created an animation snapshot, which will work in pretty much any circumstance when you need to do something like this. So I'm going to be back in the next part and we'll look at creating the rest of this back piece and possibly starting on the main claw. And in between the parts, I'm just going to go ahead and kind of just move these about a bit, just to get it into a position that I'm happier with. But as I said, doing it this way means you get the required number of copies in approximately the right place, makes the whole thing a little bit easier to place, really. So I hope you found something in here helpful, and I will see you in the next part. Thanks for watching. Hi, welcome back. In the last part we finished off our tube here, and I showed you how to come along and add these with a motion path and an animation snapshot. Now I've taken the liberty of getting them into more of an appropriate size, which took, you know, all of 30 seconds once the initial placement had been done along that animation snapshot. In this part I want to look at modeling this back piece here, this sort of curved back piece along with this port that our wire plugs into. So there are many ways of doing this particular piece. I'm going to start with a simple polygon cube, because right now we've looked at not smoothing geometry, or you know, not smoothing geometry that would have a hard edge on it. So if I come in here, we can have a look at some of the problems we might encounter. I'm just going to keep scaling this so it's a little bit bigger than my original one, because my original one didn't have the curve on the back. It's actually much more difficult to make this piece with a curved back. So let's have a look at how we might go about that. And I'm going to have to go by eye this way. So I'll just get it slightly wider than the tube, and that should be okay. So what we want on this is a curved back. So if I just zoom into the reference there, you can see this whole back piece is curved. Now, if we were going to smooth this, this would be an extremely simple operation. We just multi-cut or edge loop, so control here and one here, and then even if I just put one here, just for example, and press 3, you'll see that that's smoothed out. It's got a totally curved back, and we're all good to go. The problem is, it then comes to the fact that I've got these non-hardened edges again. So many ways to solve this. I'm going to show you a way that is perhaps a fairly complicated way of doing it, but I want to illustrate the principle of how we can use this smooth geometry to then create our own kind of geometry. So now we've got our basic shape. I'm going to go to Mesh, Smooth. Okay, and that gives me this, which is about the shape I need. But again, we've got that problem now of these sort of non-hardened edges here. So I'm going to first of all simplify this shape by cutting away some faces, and this is better done in this view. So I'm going to cut away all these front faces we need, because we don't want this to be all curvy and stuff. So that puts us back to a very straight piece, which is very nice. Okay, and then let's look at the back. So we're on unsmooth geometry right now. We've actually smoothed it in Maya. Now we'll need to close this hole on the front, which we can actually do, but I won't do it yet because I want to simplify this geometry. So I'm going to come in and actually I'm going to select these top faces. So if I do this by camera selection, that will make it much easier. So let's go into the top view and let's move our object. In fact, let's select our object mode, and let's move our object out here. And I'm going to focus in on both views, and now I'm going to use the drag selector on face mode with camera selection turned on. And this will only allow me to then select the faces I can see on the camera. So if we come in and have a look what that's done, you can see I'm only selecting those faces that it's possible for me to see on this camera. Oops, I know I wanted to really hold shift there, of course. So as I said, there are actually easier ways of creating this same piece of geometry, but I really wanted to show you how we could, really cut up a smooth model to do the same thing. Now, if you didn't want to use the camera selection, you can, of course, just come into the side view. Again, I just wanted to show you a few different ways of doing this sort of thing, and just select all the faces like so. Once I've got these faces, I'm going to go to Mesh, Extract, and that will give me a separate object with just these faces. I'm then going to scale this object downwards so it's completely flat, because I want a completely flat object here. I do not, and I've scaled it a bit too far there because the normals have flipped. So I think I've got a completely flat object now. I have, and I can always just go to normals, reverse. There we go. So I've got a completely flat object, or near as, damn it, anyway. So now I can start making the determination if some of this geometry on this object can come out, and indeed some of it can. So I don't actually need, let's see, edge mode. I don't actually need, let's see where there's edges and loops that I can get rid of. I shouldn't need any of this stuff. Okay, so let's just delete the edge on that. And the rest seems fairly essential. Okay, I could probably strip it down a bit more and retopologize, but I'm not going to. So, face mode, select them all, extrude it upwards till it's approximately the size that you need it to be. There we go. We can always scale that later. Then select the vertex just to make sure these are all nice and straight. Let's come in. are, and scale them down until they're flat. Okay, so we should have flat verts on the top and bottom. And there we go. There is our shape. But now we don't have all that extra geometry created by the smooth. We can also come in and do our own chamfers across our edges. So for instance, I can take this edge now and just go to Edit Mesh and Bevel. Okay, and that whole thing disappears. So I might have to delete the history of this. Edit, delete by type, history, and then I'm going to go to freeze transformations, and I'll also go to no, that should actually do it. Alright, now I should be able to go to the edge, mesh, bevel, sorry, edit mesh, bevel, and there you go. So I get that nice hard edge bevel that I wanted. In our case, of course, I want a bevel around the whole thing, so let's just edge selection 1, 2, 3 and 4, and bevel. Okay, now I can increase the size of that because we went to all this trouble to get it, so let's increase the size and maybe fraction of 0.4. There, done. Now, this now is still looking a little jagged around the edges, but to be honest with you, this is such a small component, I'd probably never shoot it from closer than this. However, if we did want to have it higher res, we could have started with just a higher level of smoothing on the original object. You can, of course, always smooth this one. If you don't require such sharp edges, there you go. But to be honest, I want those sharp edges, so I'm going to do it like so. So even though if you're doing a hard surface object, you can start out with high-res geometry, like we've done with this pipe, you can always start out with low-res geometry, create the shapes you need, and then extrapolate from that the high-res geometry that you need afterwards with these sharp edges. Okay, so I'm just going to make sure that bisects like so, and that should about do it for that piece. So let's make the other piece that we need, which would be, let's check the reference, which would be this piece on the back here, which is just a shrunken half sphere. So this will be substantially easier because I can just start with a sphere, and this one I'll just smooth. It'll be much easier, and I'm just going to, in fact, why am I doing that? I'll put it on in place on the reference, and there we go. Okay, let's get that approximately into position, and then R to scale it up like so, and then I can just take the faces off it. This one I'm actually just going to smooth. I could have started out higher res, but really in this case I think we can get away with just smoothing. So let's have a look at that, and we're going to have to close this in on the back view just so it's slightly wider than the pipe. Let's have a look. That seems to be about right. Okay, we are just slightly wider than our pipe. When we smooth it, we'll shrink a tiny bit, but that's fine. And let's select all the faces now. Come in and extrude that outwards. And whoops, my extrusions obviously need to be reset. And now I can extrude outwards just a little bit. There we go, just like so. Okay. So let's fit this piece to this bottom piece. There we go. Let's see if it fits. And the bottom piece might not be quite wide enough, or quite far enough back. As I say, we don't actually have a image plane of this particular view, but we don't really need one either. There we go. Okay, so let's smooth this out. And even though it's smoothed out, we still want a somewhat hard edge on it. So 1 to unsmooth, and let's cut in a couple of edge loops to try and hold the edge on this a little bit at least. So one along the bottom for a start will be needed. There we go, that holds that bottom edge a bit better. And you could come in now if you wanted to, and let me just flick that back to 1. You could, in fact, let me take that edge loop out. That should have done it. There we go. Has it? Yep. And let's just try a bevel on this. You could still bevel objects that are smooth. That's fine. You won't quite get as nice a chamfer, but you don't always need it. So I'm going to select from here, and then here, and then here, and here, and I'm just double clicking once again to get those edge loops. And just in case we ever go for the extreme close-up, let's do it on the inside too. And that should be all the edges that I want to bevel, and I'm going to select Mesh, Bevel. Sorry, Edit Mesh. Okay, and that will give me that chamfer on the outside that I would like to increase just a little bit. So fraction, let's say 0.4. Let's see if that's okay. Yeah, it doesn't appear to be too bad. But let's say, yeah, 0.5 maybe. And I'm actually going to give it an extra segment as well. So I'm going to make the roundness 0 of that. I don't want that to appear rounded. A roundness of 1 would make it appear much more rounded. And then I'm going to smooth. And I get a somewhat hard edge. Now I can also make sure that those edges are actually hard by going to display polygons, hard edges, and I've got a hard edge around there, so that's about as hard as it's going to get while it's smooth, but that's absolutely fine for this piece because it's a little, you know, tiny piece. You don't always have to do everything the hard way. Okay, and I think this thing should completely bisect my tube, so I'm going to select all of its bottom vertex and just shove them so they completely bisect the tube. Okay, there we go. So really a huge amount of ways to do things within Maya, which if you've been using it for any time you probably already know. But I quite like the fact that we managed to collapse this entire box in on itself with a smooth geometry. And then we just sliced off the top faces and extruded from there. So there are many, many different ways to create shapes in Maya. Doing it this way allowed us to keep that very hard chamfer, you know, along the edges. This geometry is now not smoothed. It would look like this if it was. We don't get that hard edge at all. We get a very hard edge across it now. And we can just check that we couldn't make that any harder, of course, by going to display polygons, and let's just check its hard edges. And there you go, we've got hard edges all along, perfect what we want. Now with a more rounded piece like this, you know, I reckon we get away with not having quite such a hard edge. Not everything has a, you know, very extreme chamfer on it like so. These more rounded pieces can often have a softer edge. Alright, so in the next part we're going to look at finishing off the last of the detailing on the back piece. So we've got these kind of cylinders to put in. That should be no issue whatsoever. I'm also going to show you how we can replicate this around the object so we don't end up, you know, again moving, rotating and all that silliness. We just want to put it in all 3 positions at once. So I'll be back in a moment, and I hope you found something useful from this exercise. Thank you very much for watching. Okay, welcome back. So in the last part we took a look at creating this cowling here, and we also took a look at doing some repurposing of some smooth geometry. Now in this part I just want to finish both of these pieces off, and one of the things I noticed is we got one of those back there that we don't need, but also that this should really encompass the pipe. Now what I'd need is to select these inside faces and extrude them inwards, but I've already done that. In fact, I've extruded the outside faces. And because I have the history on here, I can see I still have that poly extrude face active. So if I scale this cowling down until it sort of encompasses the pipe like so, or is a much better fit there, I don't think it needs to be perfect, but just so there's not a huge kind of hole there, I should then be able to simply select this poly extrude face, go down to the extrude in Z and change that to maybe 0.4, and you'll see that it grows outwards. So that seems about perfect to me. Done. Now I want to also make sure that my thing along the bottom here also comes up to meet the pipe. So I'm just going to go into face mode and select a few faces. Maybe that one too, and extrude those upwards. So that might be a bit too far. There we go. Now I could get fancy and sort of cut a hole in that and put a ring around it, but you know, it's a very small component and I doubt anyone's ever going to shoot from here. So we should be absolutely fine on that one. I just wanted to make sure that if the model was shot from over here, there wasn't just a gaping hole in around this pipe. We wanted to make sure that that looks like the pipe is actually, you know, going into something. So if I check the reference out now, it seems we've also got a couple of little cylinder pieces that need to go in. So I'll just start with a poly cylinder. And I'll scale it down, and I'm going to just scale it by eye to the reference. I've got some reference open on another screen as well, so I can see it a bit better. And I can't really use my reference for this because I actually didn't put this piece in to mine, to the original version of this that I made, should I say. And that looks like that's just a little bit higher than that. Now we could have started with higher res geometry, and in fact I think that's a bit too big altogether really. But to be honest with you, for such a tiny component, as I'm never planning on rendering this, you know, sort of from here, then this should be fine for what we need. I'm just going to come in and chamfer that edge just to help it catch the light once again, of course. So let's see, bevel edge, there we go. Okay, that's just a tiny extra detail. In fact, I think it still might be a little too large. And let's just intersect it ever so slightly. And once again, we'll need to pull that in and duplicate it across. So Control D to duplicate, and we'll just put that one approximately the same position on the other side. Okay, so just some tiny little finishing details on that back plate, just to make it a bit more interesting. And now I want to get into how we go about taking this, because as you can see there's actually 3 of these on this image. It looks like there's 2, but there's actually another one behind there. And I want to talk about taking this lot and making it on this side and this side. So I don't want to duplicate it with Control D and then move it around by hand. That would be well, for 2 pieces it wouldn't be that bad, but you know, if I wanted 16 of these to go around, then you'd be talking pain in the backside there. So, oh, and I've just noticed when we've done that extrusion upwards, we've actually gone ahead and bisected part of our geometry, which is no good. So I'm just going to pull these in a little bit. There we go. Now I need to select all the pieces. And this would be all the pieces that I want, obviously here and here as well. And I'm going to need to group them together. I need them to have one central pivot point and to be part of the same group. So once I've selected everything, Control G. And if I bring up the outliner, you'll see now I've got a group called Group 1. So that's no good to me. I'm going to call it Pipe and Housing. So done. So now I've got this pipe and housing. I need to look at where its pivot point is situated, because if I rotate this at the moment, let's see, so just press E to rotate, it'll rotate around the center of this axis here, and that's not what I want at all. I want it to rotate along the center of this pipe. So select your group, your pipe and housing group in our case, hit hit insert, which will allow you to move the pivot point, and then let's go into our fore view here, our front view in this case, and move the pivot point up here. Oops. So I'm actually moving the pivot point now, not the object. And I want it to be in the middle of this cylinder, which it is, and then I want it to be in the middle of this group approximately. It doesn't really matter that much, just in the middle of the cylinder will be absolutely fine. So there we go. So pivot point, center of this cylinder. Now we select our group. Whoops, not that one. We select our pipe and housing group, and we're going to go to duplicate special. So edit, where are we? Edit, duplicate special. Let's bring up the options box. Now I'm going to want to rotate this thing in 120-degree increments, so it's already set for that. And I'm going to make 2 copies. Now by default, it'll be reset settings. It'll have nothing here, but we want to rotate around X 120, number of copies 2, which will create 2 copies of this in 120-degree increments. So duplicate special, and there you go. That was easy. Now they appear to have come in a little bit to so insert again to stop moving the pivot, W to move, and I'm moving the wrong one, and I'm just going to make sure this is in exactly the right position for me. There we go, done. And this one, so it just came out a little bit out of position, but basically perfect. And there you go. So that's starting to look a bit more like a Dalek attacker claw. Yeah, pretty happy with the placement of all that. We need to do this one as well. So again, I need to move the pivot point of this into the center of the thing I want to duplicate it around, which in this case is this pipe. And in order to get a better look at that, I'm going to turn on wireframe unshaded, so shading wireframe unshaded, and then I can see that I'm moving this pivot point into the middle. There we go. So again, you're just going to have to duplicate special. And let's say, you know, this is nice for 3 objects, but let's just edit duplicate special and take a look at this, and then I'll show you something else. Duplicate special, great. So that's created the 3 in the right place, perfect. But what if I wanted sort of 20 of them? Well, let's go for edit duplicate special and have a look. There we go. So let's do it in increments of say 12 degrees, and then make, let's just say 20 copies for the sake of argument. There you go. So if you're making heatsink fans on something, or you know, anything that requires large repetition of geometry around a point, in this case a pipe, that's just perfect. Okay. Now for us, we only call for a couple of copies, so I just wanted to show you that, you know, it's a very useful tool for the duplicate special, can be a very useful placement tool as well as duplication. So I'm just going to go back to 2 and 120 duplicate special. There we go. Alright, that's pretty much the entirety of the back of our object finished. Now I might come in and make some of these I might come in and make some of these chamfers slightly bigger or smaller. I've just attempted to say chamfers and bevels as part of the same word, but of course they're not. So that's done the front. Now we need to look at this piece here. So easy way to create this. Let's go to our reference, and I'm going to group this whole thing and just call it claw. It'll just help me keep it organized in the outliner. Claw. Okay, and then I'm going to Control H and I'm going to hide that so I can come in and work on the reference a little easier. Now to create this shape, I'm actually going to use a polygon pipe. So let's just bring one of those in. Let's move it approximately into position, and I'm just going to rotate it 90. F to zoom in on it, and then I'm going to get it to roughly the sort of diameter that it needs to be. So we're around here really. Now the inner is too wide here, so we can go up to the attribute editor, sorry, the channel box, and make that a bit narrower, so say 0.35 maybe. There we go, perfect. And now we have to turn this into this. Now if we're going to smooth this, this becomes easier. Once again, we'll stay with this low resolution geometry. If we're going to non-smooth it and get those really crisp edges, then it becomes a problem once again of how to get this smooth curve. So again, we may repurpose some smooth geometry. And I'm just going to take this one, and I'm holding shift and I'm mouse dragging around so I get both the front and back vertex. Okay, and then I'm going to move these down. Then I will scale them out till they match kind of there and there. Okay, and now it's a case of grabbing all these vertex here and scaling them straight. So now I know they're all straight. Moving them back up to position, and now I can just actually take these two at a time and move them along the curve. So we've seen drawing a curve out with a NURBS curve. You don't always have to do that. You can, when the poly is this low, just sort of do it by eye and drag some vertex around. Okay, now that curve is looking pretty good. So if we take a look at this geometry in the perspective view now, that looks pretty good. Now if I smooth it, it'll all collapse in on itself. So let's put in some edges for smoothing here. And modeling toolkit, multi-cut with control. And just zoom in a little bit. There we go, and an edge here also, and an edge here also. Let's just make sure we got one round the back and one here. Okay, so if we hit smooth now, this will look pretty good. And again, we don't quite have the hard chamfer, so we could repurpose this smooth geometry and turn it back into something with a nice chamfered edge. So, it is sometimes nice to just be able to go mesh smooth. Let's put this up to a couple of smoothing levels. There we go. That might be a bit too smooth, because that's really high poly now. You can still work with it when it's this high if you should want to, but it's a pretty small component, so for me I'm going to go into the channel box and turn that smooth face divisions down to 2. That's more than enough. Now I can come in and grab a look at it on one of these views. Actually, this one should be fine. Grab the faces, there we go. Grabs the faces on one side. Just make sure I don't have too many of those. I do, so I'm just going to okay, that's a bit annoying actually. I think I'll grab those faces all again. So let's do this with a bit of a zoom in. Sorry, my mouse has just picked this exact moment to start playing up on me. Just a second, always the way. Right, let's grab those faces there. So just those front ones, that should do it. And mesh extract. Okay, click anywhere and we should have a different object. We do. Okay, now we need to make sure it's flat. Excuse me while I just pause and give my mouse a bash on the head. Okay, there we go. Now we need to make sure it's flat, so I can do this by selecting the whole object or just selecting its vertices, selecting all the verts, whoops, and hitting R to scale and scaling them all so they are flat. Now easier to do this in this view probably. Okay, and I can see from this view that all those verts are flat and I can't actually scale in any more now, which means they're all perfectly in line with each other. Alright, so that does this. So now we've got our high-res geometry, and this is unsmoothed. Now this is a 1 on the keyboard, so this is actually unsmoothed. Let's see if we could get rid of any of these edge loops before we come in and just convert this thing out. So that one can go, I don't need too many in here. This one, also this one probably, and I can probably take out a few more if I wanted to lower the poly count on this, but you know, retopology is really a subject for another day. This is fine for our purposes, so let's go to face mode, select all the faces, modeling tools, and extrude, and there you go. So smooth geometry that has to be smoothed, and non-smooth geometry. Okay, so for us now it's a very simple case of taking these edges, 1 and 2, yeah, perfect, and these inner ones, 1, and actually this inner edge here might be an issue, so let's just get rid of it, delete edge, and this one here is a bit close also, so delete edge, there we go, and I'll do the same on the back side, and this one, delete edge. Okay, if those edges are pressed right up against each other, it's going to make our chamfers and bevels overlap with other geometry that's in there and create nasty geometry, which we do not want. So just mesh and then edit mesh and bevel. There we go, perfect for us. Let's just make sure we're not, nope, perfect. And once again, let's just come up to offset, maybe as much as 0.5. No, sorry, not offset, fraction. Maybe as much as 0.5 on this. Get a really nice hard bevel on there. Look at that, perfect. Excellent. So this is actually quite a thin piece. Whoops. And you know, I'm going to delete the history on this. So edit, delete by type. There we go. Mouse is going again. Delete by type, history, and modify center pivot. And then I can come in and make this a thinner component and get it placed on our claw here. So don't need that one anymore. And once again, we've taken a piece of smooth geometry and repurposed it. Now, if you're interested in retopologizing this thing, you could probably come in here and take out a lot of this geometry that's now not really necessary. So delete edge, don't need any of that. Okay, and do the same thing on the back. Now, we could have done this before, but you know, it's just going to create a lower polygon version of this. Okay, and it makes no difference to your edges at this point. Whoops. That's the left one. There we go. So that's looking okay. Let's just check it out. Okay, taking some of those edges out, it's not been great for us. Some of them are actually holding the shape of the circle a little bit. So I reckon these inside too. And you know, this is good enough for our purposes. We really shouldn't need these extra edges here. They shouldn't be holding anything at all together. I think I must have last time accidentally selected something I shouldn't have and hit delete because I had some weirdness going on, but you know, that should be fine. Alright, let's get it in place on the model. So if we open up our outliner, which I've got here, otherwise just window outliner, select our claw and hit Shift H to unhide it. I should then be able to come in with the piece I just created and get it lined up with the reference. let's focus in on it this way. And okie dokie. That's going to be approximately in the center of this cube. So let's just do a wireframe unshaded so I can see. And it should be around there, I should think. Okay, and that's going to require a bit of rotational line up. There we go. And I might even pull down, because I don't want this piece of geometry to bisect. So if I go and change the axis of my movement tool now, by double-clicking the movement tool and putting the move axis onto object, I'll then be able to just move it up and down so I can see where that bisection comes in. So I don't really want it to bisect that much. And in order to help me out here a little bit, I'm going to select some of the vertex from down here, hit B to turn on soft selection, and I should just be able to move it gently into place. Let's see, there we go, and do the same here. Now obviously I'm being fairly imprecise here, and really you should take a little bit of extra time with this, but because I don't want to keep everyone watching me, you know, get the perfect placement, I'm going to call that good enough. And it will just really help when we render to show that this is a piece that's kind of been welded onto this piece. If we just bisect that in there, it looks a bit like, you know, it's all one continuous piece. Sometimes a bisection is fine. Obviously we've got some here. And you don't always have to do this, but just, you know, the option is available. You can always shape things to the surface. Yeah, let's make that a little bit thinner, even more. And then Control D to duplicate. We've got another one that comes out here. And our claw will go in the middle of these two. Now, I'm making an educated guess as to how wide that would be, but I think it's about right. Again, when I'm doing a tutorial, I don't like to spend hours and hours and hours making sure everything is perfectly aligned. I do that in between the parts, but yeah, as you can see, these are pretty well matched up with each other. Okay, so now we just need to make our inner bits. Let's have a look. It appears to be one large washer, one kind of small washer, and one bolt that goes through the middle. So that's really not that difficult. Again, it's just poly pipes. Okay, let's move this up here. And let's get this about into the center. Okay. And I want to get my placement quite good here. And I just want it to bisect a tiny bit, because then I'm going to bevel it, and that will appear that the surfaces aren't quite mated like you'd expect to see in a kind of bolt and washer situation. So let's come to the attribute editor, the channel box, sorry, and let's change the inner thickness of this to say 0.2, maybe 0.22. There we go, that should be about right. And Control D, and then I'm going to scale this one down so it matches this one just a little bit smaller. Okay, perfect. And you know, I think with these pieces, we're going to be absolutely fine because they're going to be so small. I'm turning B to turn off soft selection. We're going to be absolutely fine just to grab them, bevel them, and then smooth them. Whoops. There we go. So edit mesh, bevel, and that's too big. So fraction point, let's say 0.5. That's fine. Actually, maybe a bit bigger, 0.8, and segments up to 2 because we're going to smooth it. And let's smooth it, and that will be perfectly fine for this kind of operation. You could again have started with higher res geometry, of course, or with geometry with more subdivisions. but I think for this will be okay. So I'll press G to bevel again, and I'll need to turn this segments to 2 and fraction to 0.08 maybe. And there we go. Okay, and smooth, and there we go. Now I'm going to grab this and I'm going to scale it to size. So just like so, perfect. And this one, scale to size, there we go, perfect. And because we have smoothing now, these have shrunk a tad, so I'll just scale up a little bit. Same with this one. There we go. So that gives us that, looking rather nice. And you know, I'll do the bolt now. That one's a bit too far hanging out. There we go. I'll do the bolt that goes to the middle now, because I would assume there'd be some sort of bolt holding these claws. So again, let's do this one same way we did with the others, but just for the sake of argument, because this one's going to stick out a little bit more than the washers, I'm going to just hold J to get that to lock its rotation. I'm going to start with higher res. Okay. Whoops. And F to focus in on it. Can't quite see where I'm moving it at the moment. And let's use the appropriate view to get that in the middle of here, like so. Okay. So can't actually get a good look at it on that view for some reason. My viewport's just playing silly beggars. Okay, in a little bit, and now this one, and shift select this one and bevel it again. Okay, and this time I want quite a large bevel. I'll just expand that out so it's like so. Okay, perfect. And I'm just going to go up to display polygons, edges, and make sure I've got hard edges on this thing. I have. Okay, there we go. So there is the piece for the claw. Now to duplicate it around, of course, we just select it. And you know, to be honest with you, these look fine because they're such a small component, but again, if I'd wanted that hard edge on them, I would have had to start it off with geometry with more subdivisions, so like I did here. And you know, this is repurposed geometry that we used by using the smooth function and then cutting out some faces and using those. So let's just duplicate this around the model before we call this part quits. So Control G to group this. And then once again we'll need to move its pivot, so insert. Now we know it's at the center of the grid. We know it starts the pivot point for the group, or know it starts at the origin of the grid. So if I just select this group, and I'll call these, not sure, claw holder for want of a better word, all I have to do is get this in the center of the sphere. So there is our sphere center on that axis, and here it is on this axis. Okay, so I'm going to select everything in this group like so. Its pivot point is here, so I just have to go now, edit, duplicate special. Okay, rotate is 120, scale is 1, number of copies is 2, duplicate special, so just put those on for me. Magic. And they're even pretty much in the perfect place. Looks like we missed it by a millimeter, but not to worry, we'll just select the claw holder group and just move it a little bit. I'll center the pivot on the group, and then it can just be moved, tweaked if you will, ever so slightly into place. There we go, done. Okay, and this one might have the same issue. Yeah, it does. It's kind of a millimeter out. It's because I didn't take enough time to place the pivot in exactly the right spot, but it's near enough. So in the next part, when we come back, we'll look at doing the claws, and then we'll be just about done. So I really hope you've been finding this useful so far, and I'll see you in the next part. Thanks for watching. Hi, welcome back. So at this part we are here with our claw, and we want to get on with making the actual main claw piece now. So I'm just going to disappear into the front view, and to do this I'm going to use this part, the reference, and I'm just going to draw this out with the Bezier curve. So create Bezier curve, and again the same as we did last time, I'm just going to get it the right approximate shape here. Just about like so, and to close the curve, press Ctrl Shift and click on the last point. Now the curve has been closed, we can come up and press Ctrl Shift and start moving out our Bezier curve so it fits the dimensions of this one. And I'm not going to be too precise. And let's go this way. Okay, and that looks about right to me. I might just curve one of these down here, although I'm going to be outputting very low resolution geometry, so I don't really need to worry about curving those. Okay, and I'm going to press Enter to close the Bezier curve. Now, we've looked at using these curves before to make pipes and stuff. This time I want to use them in a slightly different way. I'm going to select this curve, press Ctrl D, move it out a little bit, doesn't really matter how far. Select first curve, second curve, spacebar, go up to surfaces, and this time I'm going to use loft, which will make a surface between these two curves. Now I'm going to leave it on its default, which I believe it's on, which will be NURBS output. That's output straight to polygons, quads, and control points. And loft, and that gives me this, which doesn't really look a lot like our curve, but as soon as I smooth it, it starts to look more appropriate. So a couple of things we can do now, and one of the first things I want to do is to just get a face on this. Now, because I intend to smooth this, I cannot simply select the entire edge and then hit fill hole, because that will indeed fill the hole there. But it will cause other problems too, especially during smoothing. In fact, let's take a look. Mesh, fill hole. Okay, so that's just not going to work for a start. If we come over here and let's look at why it's selecting all the way around there, vertex. So that's fine. Okay, but regardless, I'm going to have problems filling that hole in that way, especially when it comes to smooth it later. And this surface is also reversed, so let's just normals reverse. There we go. I'm going to actually use the Append Polygon tool to fill this hole in. So if you go to Mesh Tools, Append to Polygon, it'll highlight edges in green I can click on. So let's try this one on this one. And then up to this one, yeah, that's fine, and then over to this one, no, it doesn't like that, so backspace, take the point away, enter to finish off, and then G to load in the Append to Polygon tool again, and that time I'll take this one and this one, that seems to have worked, so enter, G, and this one, there we go, magic, whoops. Let's just keep going around with the Append to Polygon tool here, and that should do it. Okay, so that's given us sort of a basic framework to work with. Now I'm going to come in and get rid of all the faces that I don't need, which would be all these, and I missed one, and it looks like I missed more than one actually. Let's just double click there to get that whole loop, and this face here. And there we go. So we're left with this shape, which we then smooth out. You'll see it's got some problems. So rather than going in and checking these out ourselves, there's a couple of things we can do first. One of them is just edit mesh and merge components. This will merge any stray verts that are left together. The other one is mesh cleanup, which will attempt to clean up the mesh of any non-manifold geometry. So let's just hit cleanup and 3, and now you can see we get a much better result, which has saved us a bit of work. So we can now get this very low poly version back into the correct shape. So I'm going to take both of these and sort of move it downwards like so, and then I'll have to take this one on its own, move it up here, maybe this one on its own, and you can see I'm just getting this very low res mesh back into shape. Okay, done. So there is the very, very low res version. Now let's see what happens when we try and insert an edge loop. And we're absolutely fine to insert edge loops. So we don't really have any problems with the geometry. Not that there's actually a lot of geometry to have any problems with. But I'll just select the face now. Select all the faces and extrude. Just change its smoothing level. So I'm going to extrude about that far. I could almost rescale later on, and that makes me like so. I can then start to put in some edge loops to hold the smoothing. So one here, here, here. And before, you know, we've repurposed smooth geometry to help us get a cleaner edge on it, but with this claw I may just go ahead and leave it smoothed. Actually looks okay when it's smooth. Let me just check that out. We've got an issue down here, might just be a viewport. Let's have a look. No, we could definitely do with some edges down here as well. Okay, that holds that edge in a bit better. Okay, so we're still not quite there. It's still not looking great, and that's because we need yet more edge loops to hold the whole thing together. So I'll put another couple here, and I'm trying to get these evenly spaced without you know, going bonkers for the sake of the tutorial. And now we're looking a lot better. Let's check ourselves for shape. We're in approximately the right shape. Okay, but this is still pretty unsmooth because we have very low resolution geometry. So let's just go up to mesh and smooth. And now we're smooth, but maybe we're a bit too smooth now. Now we're extremely smooth. Let's knock that down a bit. Channel box, poly smooth face, divisions. Let's try just one. So a bit of a higher res, and then the smooth preview takes us up to pretty damn smooth. Now we've still managed to keep some semblance of an edge. Obviously, if you wanted to keep a really hard chamfered edge, then we'd have to cut out some faces here and repurpose the geometry. So let's go ahead and do that. Let's focus in here, and I can't see what I'm doing, so I'm just gonna move this outwards. Okay, and I'm going to do a face selection. So again, as we've taken smooth geometry like this before and repurposed it, I want to take this smooth geometry now and repurpose it. So I would just extract these faces, then extrude backwards, and, you know, repurpose from there really. To be honest with you though, looking at it, I am finding this particular shape fairly acceptable at the moment. I can kind of see the edges on it. It's not quite as chamfered as it would have been had we used the same technique we did here, but I will leave that for you to do if that's what you want. And I'm going to just move this back to 0 in Y, and then I can pull it out this way and finally push it up this way and get it in between where it needs to be. and I want it standing slightly proud of our curved surface. There we go. So something like that. I want to actually see that it's not, and it might need to be a little fatter. Just center its pivot before I scale it. So I'm going to come up to modify center pivot. There we go. And just move it a little bit this way. That's good. Okay, quite liking that. So of course now I'd need to duplicate it round 3 times and put the teeth on it. Now before I go into putting the teeth on, because I'm going to show you a different technique for placing this geometry, I want to come in here and look at this back portion. Now I've seen lots of reference where this back portion has holes drilled in it, and I thought it'd be quite nice to show the technique for that. So on the stuff I've seen, this has got sort of 8 holes drilled in it. So I'm going to create a sort of Boolean drill bit, and I'm going to take a, let's see, one of these. I'm going to give it slightly more geometry, so I'm going to go to 40. I'm going to put a bevel on the bottom edge, so I'm going to select the edge and bevel it in. So edit mesh, bevel, and I'm going to put a fairly big bevel on, there we go. And then for this top edge, I actually can't put a bevel on it. I want a reverse bevel, and you'll see why in a second. It's easier if I just build it, demonstrate it, and I think it will be easier to see that way. So I'm going to do a reverse bevel here, for which I need to put, or reverse chamfer in this case, a edge loop at about the same distance as the bottom one, so that might be a bit too much. I'll just slide that up. Then I'm going to select this surface and just scale it up to create a reverse bevel. Okay, now I'm going to take this and I'm going to use it as a drill bit, and that will make perfect sense in a moment. So let's pull this back to here, and for now I'm going to hide this piece, and I'm going to scale this to the right size. So let's scale this in and get it into position, and this will be the position of where I want my hole drilled, and soon this reverse boolean will make sense, I hope. There we go. So I'm going to come in now, I'm going to select the object I want the hole cut in, I'm going to select the object that's doing the cutting, and I'm going to go to create, actually I'm going to go to mesh booleans difference. And you see that's cut a boolean in there with a nice chamfer on the bottom and a nice chamfer on the top. So we've cut a great hole in there, and you know, just having the bevel the right way for the bottom and the wrong way for the top allows you to create these sort of boolean drill bits. So if we just undo that, we can use our duplicate special to create a whole bunch of these drill bits that go all the way around, and then we can use the boolean again. So let's come in and go edit duplicate special. Okay, and in this case I want about 8 of these holes going around, so 45 degrees, and number of copies is going to be 7, because I've got one already. But the first thing we need to do is put the pivot point at the center of this. Sorry, I forgot that fairly crucial step. And this time we want to be accurate. So let's come in and get that right at the center, because you know these drill bits, they're fairly small and I don't want to be spending a lot of time replacing them around the surface. So that should be about accurate enough. Okay, so with that done, I can now hit duplicate special, and we'll see all of these have gone around the surface. And we'll just make sure that they're all lining up where they're supposed to be. They are. So now all I need to do is select first the main piece of geometry I want to drill into, and then go ahead and select the drill bits. Now some of these might be a bit difficult to select, but they seem to be doing alright. Okay, and this first one even I don't need. Perfect. Alright, now let's try this. There we go, mesh booleans difference, and hopefully that will have got it. Looks pretty damn spot on. And I'm not going to have one up here because I'm going to bring that fin back. So there you go, perfect. And you know, this looks great. It's because of the way booleans work, especially in Maya 2015 they've got a lot better, but because of the way they work it means this object now would be more difficult to edit. So you should really leave any booleans you want to do right until the end, because if I wanted to come in now and say put an edge loop around here, you'll see there's going to be a problem. I'd have to re-topologize this whole thing, which you really don't want to do. So as long as you've finished editing your surface, you know, there should be no problem adding these booleans, and these worked out fantastic, I think. You know, they add just a little extra dimension. Looks like you've spent quite a bit more time and effort getting that in there, and you know, it looks very nice. So when we come back, we'll look at placing these claw kind of grabby bits. I'm not quite sure what you call those, but claw grabby bits seems alright to me. And of course we could use the duplicate special on this to copy it here and here, but I'm going to wait until the rest of the claw is done. So I will see you in the next part, and I hope you've picked up a few pointers in this one. Thank you very much for watching. Hi, welcome back. So in the last several parts we've created our claw here, and one thing that I didn't like is as I look around we used smooth on this claw, so if we unsmooth it we can see the difference. The difficulty is, as we've been saying all the time, this no longer looks that hard edged, which I thought for the claw we might get away with, but now I'm seeing the razor sharp definition on this piece. I really don't think this is good enough, so I'm going to unsmooth it, and I'm going to start by just simplifying its geometry. Now I would have done it this way regardless of whether I was going to smooth or not, so this is, you know, just a quick way to create better geometry for what we need. So let's get rid of all these edges up here, because we're looking to have just one edge left really. And there we go, that should do it. So let's go edge, delete edge. Okay, and that was too many. So it appears that I've got one there that I can't get rid of. Just one at the bottom. I think I've selected the entire bottom edge there, folks. So just delete edges. Okay, that will do for there. And I should be able to delete edges here. And that should be fine. Alright, now I'm going to come in and select these faces. So interface mode, and I'll just select this face, this one, 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 and this one, and now I can mesh extract. So let's just hit extract, and let's go to object mode, W to move. I'll have to center the pivot. Hang on, there we go, that's centered all right. There we go. Now I'll make this straight just by vertex, straighten that up, and I've missed one, I can see it. Okay, better done in one of the orthographic views. And we'll know when this is straight because we won't be able to scale it anymore. So there we go. Alright, so now we have this, but you know, this is not perfect. This is not that smooth. If we just use this now and put a chamfer down it, then we'd be in a bit of trouble, because you know, anyone could see that that is not a nice smooth curve. So before I smooth this, I'm going to take this piece here, I'm going to go to edge, I'm going to select it, and then I'm going to use the slide edge tool, and I'm just going to slide that over to there. Okay, what I'm looking is for these faces to be about even. So the more even I can get them, the happier I'll be. But to be honest, I think that is actually simply superfluous to requirements, that edge. So there's no need to slide it till it gets more even. We didn't need it at all. Alright, so there we go. now we have this. Let's go to the modeling toolkit and extrude all these faces. Now we have like so. Actually, before we do the extrude, let's do a smooth, so we're all nice and smooth. Mesh, smooth. There we go. Aha. I really don't like what's happened here. So something there has gone wrong. Let's come in here, look for some hidden vertex. There we go. Done. Get rid of those. Right, now mesh smooth. There we go. Lovely smooth geometry. But we've got edges we don't need. And delete edge. Okay, we don't need those edges. We would have needed them if we were going to smooth the object, but as we're not, we don't. So now face mode. Okay, and extrude, which gives us this, which looks perfect to me. Now I just want to select the edges I want to bevel. So this one and this one, and I'm double clicking to get the whole edge loop. And I'll just select all the outside edges here. Let's spin round the back of the object and make sure we've got these. And make sure we've got none we don't want. No, we look to be pretty good. So edit mesh, bevel. There we go. It's a pretty small chamfer. So let's go up to the channel box and change the fraction to say 1. Still not big enough. 2. Let's see if we're having any problems down here. We don't appear to be. Okay. So that now looks like a razor sharp edge. So let me just get off this slide on edge tool by pressing Q. And I'll just come here and let's do a comparison. Let's smooth this one back over. Okay, this one's like a razor sharp edge hard object. This one's a bit meh. So that one's gone and this one's taking its place. There we go. And maybe it could be a little wider. Done. Okay. Perfect. Lot more hard surface, hard edge feeling from that now. Sorry, I should have done that straight away, but I really thought we'd get away with a smooth for once. But, you know, after we'd done all the hard work on these parts to get them looking this crisp, seemed a shame to leave the big claw with a sort of softer edge. Alright, let's talk about putting these teeth on. Now I'm going to use a script to place these teeth, but really you could just place them by hand. I'm going to just use a polycube, and all I'm really going to do is select the vertex on the bottom, hit R, scale them in until we create sort of a toothy point. There we go. And I'll probably make these a bit wider, maybe even a bit narrower, depending on how I feel. Now that's going to, whoops, don't want those. Now this is going to be a bit wider probably, and then I'll bring it up and put it on the claw. Now as I say, you will be able to just take these, you know, you can look at your reference to get a scale, or you can do it by eye. I'm just going to have a quick look at the reference to make sure, you know, I'm not completely out. So now I've got my object, I can come up and it looks to be about the same size it is on the reference. It might be a bit narrower, but I quite like that. So, and then you could rotate it round to begin here, and then you could place it on, and there you have it, you know, your first tooth, and then you duplicate across and across and across and across and across. But that's a pain in the backside. You could also make a curve that followed around this, and then use a motion path to lock this to the motion path, and then use a animation snapshot to do it in exactly the same way we did this. Or you could use a script that I use all the time called SPPaint. Now SPPaint is a great little script. You can get it here on Creative Crash. It's just under Maya, Script, SPPaint, and I'll actually bring up, or I'll actually make a note of the website address in the README file for the tutorial. So once you've downloaded that particular script, you simply put it in your Maya scripts folder. Now, depending on your OS, that could be in different places. If you're on a PrettyBox Windows system, then you'll want to put it into your Maya scripts folder, which is normally My Documents, Maya, your version number, and then scripts. On Linux, it's in the home folder in pretty much the same place. Mac, same thing. So you might need to look up where to put your scripts. But once you've got it installed, and basically you just download it, take the script and plonk it in the scripts folder. You may have to restart Maya, so that's one thing to keep in mind. So once you've put that in your scripts folder and restarted Maya, you should just be able to type SPPaint 3D in this mailbox here and hit go, and that will bring up SPPaint 3D. You can, of course, put it on a custom shelf, which I have done here. I've got it on a shelf called Tutorial, just in case you didn't know how to do that. I'll go into the shelf editor. I'll just delete shelf. Yep. And then I'll go into the shelf editor and just show you how that was done. Nothing to it really. So let's go shelf editor and let's create a new shelf, which I will once again call tutorial. Yes, and then I'll create a new object on that shelf and I'll call this SPPaint, and the command for SPPaint will be exactly what we typed in that mailbox, with a semicolon on the end to tell it it's the last command that's coming. So it's mail, basically same as we typed in here. Save all shelves. I've now got a tutorial shelf with a button on it I can push that will bring up any custom script I want, or indeed any of the standard Maya commands. So now I've got my SPPaint going, and I've got my little tooth here, and I want to make sure the little tooth is actually a little bit longer than the actual claw. This will help me later on. I'll put that down there. Pivot point is going to be important, because let me explain to you what's going to happen. I'm going to paint this geometry on this geometry, while this geometry aligns to the surface of this geometry. So that sounds complicated, but really it's quite simple. I just select the geometry I want to paint with and click add. I select the geometry I want to paint on and click add. And then I go to place, let's try that, and I just simply place the geometry on it. And you'll notice that it's actually moving. It's rotational, depending on where I try and place it on the surface, which makes it great for putting stuff like this down. But it's also kind of weirdly intersecting the geometry, and that's because of the location of the pivot point. So as we've seen before, where you put your pivot point can make quite a bit of difference. So let's just move this SPPaint here for now, and if I hit W for this object, I'll see its pivot here. So let's move the pivot point. Insert to move the pivot point. Let's move it up till it's pretty much in line there. I'm just going to put it slightly under, so this will then bisect our claw geometry a little bit. And other than that, I won't need to do anything. So now when I come up here, place, oh, that's much more aligned, but it's upside down. So that's not really an issue either. We'll just tell SPPaint that we want it rotated a minimum of 180 and a maximum of 180. And now it will be the right way up. Okay, now that's a great thing as well, because I could say a minimum, say 100, and a maximum of 220 degrees, and then I'll get a random placement depending on when I put it down. So excellent for placing random instances of geometry as well. You know, just an all-round nice script to have, which is why I bring it up. As I said, this wouldn't have been too difficult to do by hand. Whoops, and I really don't want to delete the master object there. This wouldn't have been too difficult to do by hand, but if you have the script lying around, you know, you can find all sorts of uses for it. You can even do it the fast way. Let's say I wanted to get this, and I'm just going to paint this on here. So rather than saying place and place, I can actually say paint, and with a distance threshold of 0.4, I'll get something like so, and it just paints up there. Now we're going to want to change that rotation back to 180, and you can play around with scale as well, which is cool. And I can just paint teeth on here now. So I mean, there we go. There's all the teeth I would want, and I might need to tweak that distance threshold a bit, but you know, it's there. Really quick way to place the geometry. Now I'm just going to make my teeth a bit wider because I don't actually like them that thin. There we go. And then I'm going to come in and I'm going to place my teeth. So I'll just hit paint. And I just really just have to paint up there. So let's get it all done in one fell swoop. And that's pretty fast, really. So there we go, and we are done with teeth. Now, depending on how many you want, I think I actually had far too many teeth on the original, so I might have a few less now. But, you know, depending on how many you want, you can just keep painting, whoops, all the way back, as many as you want. So it takes, when you're doing this with the paintbrush, I normally just use the place. It is a bit slower, but, you know, it is then again a bit more precise as well. So it depends. If you've got a real steady hand, you might want to try it with paint. It can be done. But I'll just place mine. Doesn't take too long, really. It's just really nice. The script orientates them to the surface for you. You know, I can make instances of this geometry, which is useful. I will show you in a second. There we go, and that should be about enough teeth. Now the nice thing about all of these copies I've just made are actually instances. So if I take the geometry here and grab these vertex, say here and here, and then move them, all the instance copies will move too. So if I suddenly decide, I wonder what that looks like with really thin teeth, I can come up here and here and go, okay, that's what it looks like. Just a benefit of making instances of these instead of copies. Right, but now we've got all these teeth and they're all they're placed nicely orientated to the surface, but they're not actually aligned very well. So let's grab them and do a mesh combine. That'll temporarily combine them into one object, and then I can grab the vertex all together, scale them flat like so, and then just move them so they're under the lip of that lovely hard surface geometry we made. There we go. And I'm going to want to do the same on the other side, of course. Okay, and then just under the lip of that geometry, there we go, object mode. And now we have some precisely placed, nicely aligned teeth. So, you know, make the determination yourself whether you want SP Paint for that. SP Paint for just that is probably overkill, a little bit. But once you've got it, try it out on some other things. I mean, as I said, I've used it for roof tiles, trees, rocks, grass, many, many things. So what I'm going to just finish off with is I'll just get rid of this, and I'll get rid of this, and I'll group this all together as one object. So just grab all these separate components here, and then finally all of the teeth, there we go, which have now been combined into one object. So that's it, everything, and then Control G to group it. And if I pop open my outliner now, so window outliner, I'll see a new group, and I'm going to call this claw group. Now all of these are empty nodes. When we delete the history, all of these will go away. They're just empty transforms. So I could just take all of these and hit delete. Whoops. First, let's delete the history. So edit, delete by type, history. And now I can take all of these and just take them away. So we've got this one claw group. We're going to need to get the pivot of it in the center of this. So let's hit W. The pivot will appear down there. Insert. Let's come up. Let's do this a bit more precisely, shall we? And let's get the pivot in the middle of this. There we go. And there we go. Now I'm not going to be too precise. Close enough. Okay, so now it's just a quick duplicate special on the group. So edit, duplicate special, where are we? And number of copies would be 2, and rotate would be 120, and duplicate special. There we go. Okay, they ended up being a little misplaced. Okay, I wonder why. Let me double check that pivot point, and I can see from here that I haven't got the pivot point quite in the center, it looks like. No, I've got it one span above, so apologies. That was a bit clumsy, but you know, sometimes these things happen. Alright, so close this down and let's just do that duplicate special. Edit, duplicate special, should have the same settings as last time, and there we go. So there you have it, the finished Dalek attack claw, or attack weapon, or whatever it was called. You know, and it's a very nice example, in my opinion, of some hard surface modeling techniques. We've got rounded corners with razor sharp edges. We've got very nice sharp edges on geometry like this. We have, you know, a piece that's been created that has these great looking drilled, beveled, chamfered holes in it. All of the hard surfaces look hard. We've had to smooth very little. I mean, the only things we've smoothed are the true rounded pieces. This piece, this piece, this piece, this piece. All of these other items are actually hard surface items. Okay, including the claws. Okay, so there you go, really. This will be all the modeling we'll be doing during this tutorial. I'll be back for one very short part where I show you how I just got my ambient occlusion renders, because I figure if you've got this far, especially if you're new to Maya, you're going to want to render this this model out just to show it off a little bit, and for you to see yourself, you know, it helps to get a good ambient occlusion render to check if there are any defects, which I very much doubt there will be in this, but we shall see. So I'll be back just with one final quick part on the rendering process. So I really hope you've enjoyed this tutorial. This brief look at hard surface modeling in Maya. If you've got any questions, you can get me personally at David or Dave at SimplyMaya.com, or please use the forum. Plenty of helpful people there that will probably be more than happy to answer any questions you have. Alright, so thank you very much for watching, and I will see you in that final very quick part where I just quickly show the ambient occlusion rendering process for this. Alright, cheers. Thanks for watching. Hi, welcome back. So as you can see, I've got our finished claw open here, and I just wanted to take a minute to take you through the little bits that I did in between this part and the last part. So I've added this, which was on our reference, which is basically just a cylinder with a cone on the end. I'll show you how to do that in a second. And I've also added these, which are just polygon pipes, so nothing we haven't seen there. I just wanted something for these cables to plug into. So the cylinder was literally one of these cones. So I'll take one of those, and I've obviously changed the background a little bit, and I'll explain that in a second. So I'll take one cone like so, and then one pipe. Simply scale them to the same size, or indeed I would have left them on their default size, but either way it doesn't matter. And then you want to connect this one and this one together by merging these vertices. Now, if you're unsure how to do that, the first thing you'll need to do is take out the faces. So you don't want this one, and you also don't want any of these faces here. You never want to be connecting something with two faces in between. So I'll use the drag tool. I'll go on to face selection, and I'll just drag around there to select all those faces, hit delete, go back to object mode, move this one up. I'm going to put my marquee tool back, select both pieces, mesh combine, and then I can simply edit the verts, grab them, shift, right click, merge vertices, merge verts. Or I could indeed use the target world tool. And then I'll go around, I'll just push G to repeat the same operation until I've merged all the verts all the way around the object. Okay, so that was basically how I created this piece here. Nothing to it really. What I really wanted to discuss in this part was simply rendering out of this, because you've probably seen the renders we have on the site. They look something like this. Okay, and I really like this way of rendering out a model that I've just done. It's, it looks pretty in my opinion, and you can see the wire on the objects that it's necessary to see it on. So this is contour rendering in Mental Ray. So I thought I'd show you how I pulled this off and how this final render was achieved. So in order to get the background something a bit more interesting, you see it curves upwards. I quite like that as well. I just made this simple polyplane, which was basically done like so. So take a polyplane, scale it upwards, and this one's obviously been twisted. I then went and reduced the number of subdivisions to 1, and then I put, with the modeling toolkit or the split poly tool or the insert edge loop tool, it doesn't matter, I just used this modeling toolkit with control held down, took that, selected this edge, moved this edge up and a little bit over until you've got the desired sort of level that you want, and then press 3 to smooth, and that will give you this sort of bent in background. I then used a smooth mesh on mine, so just mesh smooth, because I wanted visible in the render the actual geometry of this background plane, simply because I thought it was a nice counterpoint to the model itself. So, regardless of what you put in the background, or even nothing at all, I want to show you the technique for getting a wire on top of a ambient occlusion render like this. So the first thing we need to do is, I'll just get rid of this because it's not necessary. The first thing we need to do is apply a material to our object. So if I use a Lambert or a Blinn or a Mental Ray material, I'm going to have to light the scene, and I don't want to do that. So I'm going to use a surface shader, because the surface shader won't take into account any of the lights in the scene. So if I drop a surface shader on, and within that surface shader put an ambient occlusion material, all I will get is the ambient occlusion. So I'll give you an example with this sphere. In fact, first I'll just knock out a quick test render. So I'm going to just render a 720, and I'll just knock out a quick test of what we've got thus far. So I'll get this into a position and hit render. Now before I do that, one other thing I will go over, just so you can see it, is my camera settings. So if I select here to select the current camera, which is currently perspective, and I go up to the, let's see, attribute editor, and I look down, you can see my focal length is set at 110 mil. Now by default it's set at 35 millimeter, but if I do that, you'll get some bowing on the lens, sort of a fish-eyed effect. So when you're doing a product shot, or you want to shoot something, quite precise, it's better to use a longer focal length, and that way you don't get the distortion. So you can go higher still, so 180, although I find 110 is normally about fine, and there you go. So I'll leave mine at 110. Just something to bear in mind. If you're getting some distortion on your models when you zoom in closely for that render, increase your focal length. Alright, so after increasing the focal length, let's get a quick render of what we've got on screen. And this should take a couple of seconds, depending on the anti-aliasing, and this is, which is quite high on this shot, I can see, and this is what this looks like when you render it with just Maya's standard default light in the scene, which should be there automatically. If you hit render now and you see nothing, you want to come in, look under the common tab, under render options, make sure enable default light is on. Okay, now normally I wouldn't do a render with this setup. It just, if you compare it to this one, you're not going to want to show your model off like this. Really doesn't give anyone a feeling of sort of the nicely beveled edges and the smoothness of the shape. So first things we want to do, put a surface shader on this. Okay, so just under Maya, if you look under favorites, you should have surface shader. Now what this surface shader does, it becomes one solid color, and it won't take any notice of the lights in the scene. So if and I'm just going to turn down my anti-aliasing so this doesn't take as long. So I'll just whack it down to 1, and I'm using legacy sample mode for a reason I'll go into in a second. And let's just whack this across, and you'll see the surface shader just gives me a bright white surface. Doesn't pay any attention to the lights. So that's great. That means we don't need to set up any lights, but we do want something, with some shade in it. So we want an occlusion node. So let's come in here, and under the out color of the surface shader, let's throw in an occlusion node. Now this is under mental ray. Let me just search. MIB ambient occlusion, there you go. So this will bring up an ambient occlusion node, and if I render now, you'll see that this sphere looks a bit better, although it will be terribly grainy. Okay, so that gets the occlusion on it. Now I'm going to increase the spread of the occlusion. I'll probably double it, and that will just help me get a smoother transition. And I'm going to leave you to play around with these occlusion options. There's not that many of them. Most of them are fairly self-explanatory. So now I've got more spread on that occlusion. I can come in and increase the samples. The more samples, the smoother this is going to be, the less grain you're going to have. Unfortunately, the longer it's going to take to render. So I tend to leave it quite low, probably about 32 or even 16 while I'm doing the test shots, and then at the end I'll crank it up to 128, maybe even a little higher depending on the final resolution I'm going to render out at. So this will do for testing. So now I've got this kind of white color, but I can change that. So if I come here and make this a little yellower, maybe not that insanely yellow, and maybe a little darker, a little less saturated. The light color of the occlusion now will now be yellow, and the dark color will still be black. So we could probably help this out somewhat by making the dark color more of a darker brown. I'm not going to play around with it too much. I just want to get it to approximately where I had it before. And there you go. You can see that comes in now slightly yellower. Okay, it's maybe a little bit too oversaturated, but we'll deal with that in a second. Now, what I did when I rendered out was I used two different colors. I wanted to bring in a darker color to accentuate some areas, just to break up the model a bit and make it easier to see what was going on. So for that, we'll need another surface shader, and the reason why you can't see the materials going on is because I have default material armed. A surface shader by default will just appear black. So, once you've got a surface shader on the whole thing, it's going to make this quite tricky to see. If I come in here and apply that same surface shader, my render view will just look like this. So I tend to use default material when I'm working all with surface shaders. And I'll get a render of this now so we can see what it looks like with just that one surface shader on it. So there you go. Even with just one surface shader and with that occlusion node plugged into the out color of the surface shader, we start to see a lot more definition in our model. We can actually kind of see what it will look like when it's lit properly. So I've got all the occluded shadowing in here, and it just really helps to pop out that definition. So let's go ahead now and make a different surface shader with a different occlusion. So again, assign new material up here to your favorites, and we want that surface shader. Again, we're going to want to put to the out color a mental ray occlusion node, so MIB ambient occlusion, and I'm going to put the quality to 64, and this time I'm just going to turn the bright to dark gray. So then the color will be lightest at this dark gray and darkest at this black. Now I never like to use 100% black, so always tone that down just a tad. Okay, now we need to select the areas of our model that will have this darker color on them. So I believe I set mine up something like this. I'll obviously let you pick out which parts that you want to differentiate, but I believe this was how I'd set mine up. So I'll then assign an existing material, which for us is surface shader 2, which is probably go in and call dark ambient occlusion. Okay, and you can see why I turn on that default material, because it gets a bit tricky to see when you're setting up your camera shot. And this time I'll re-render it again, and we'll get a nice kind of separation in the model. Okay, so there we go. That helps pop out these pieces here. Now we still want that nice wireframe look. So if I just flick back to one of the renders, and the background, I'm probably going to pop out and differentiate the color of that as well. So let's come in here and just select the background, and once again just assign a new material, and your process should be fairly familiar now. We want that surface shader and ambient occlusion node, and I'll set this one to 64 too, and I'll just leave it at default. I'll probably increase the spread a bit, and the same with the spread on this darker material. So that will just help the spread become more apparent, which, as I'm just using ambient occlusion in this render, I want a sort of more apparent spread of the occlusion. Okay, so from there, all I'm going to do is take this one and assign the dark occluded material to it, because I actually missed that. I seem to see, yep, and probably this as well. And again, this is just my preference. You can obviously pick which parts you want to be which color. And from there, we should have pretty much most of it as it is in my final renders for the sites. Let's just take a look. Okay, so that's definitely getting closer to my final render. This yellow's a bit harsh for me, so I'm going to go in and tweak that before I do anything else. So just pop it open and just probably make it a little lighter, a little nearer to white. You don't want too much yellow. I just wanted to separate it from the background. Now, we've got basically the occlusion, and this means we don't need to light the scene to see what's going on in here. What I would like now is to get a wireframe on this. We are supposed to be showing the model off after all. So the way to do this is, first of all, if you're on Maya 2014 or 15, under quality you'll be set to unified sampling by default. Now this is great, but it won't work with mental rays contour rendering. So you're going to have to go down to legacy sample mode, and of course then you just control your ambient occlusion with max sample level and anti-aliasing contrast. Now my final settings were a max sample level of 3 and anti-aliasing contrast of 0.05. This will give you a pretty smooth render. If I zoom in on this one, or just take it to 1:1, you can see everything is nice and smooth. Now the render time on this was about 9 minutes for 1020p, but your render time may vary depending on the machine, of course. The one I'm on right now is not particularly powerful, so maybe you'll get it done a bit faster than that. Alright, and if you need speed for whatever reason, you'll need to come in and crank this max sample level down. So as soon as you're set onto legacy sampling mode, if you're on a version of Maya that isn't default, we'll need to go under features, and you'll see a tab down the bottom called contours. Now you'll need to enable contour rendering, and by default I believe the oversample is set to 1. So I'm going to show you, and the filter support is set to 1, and none of these are ticked. So contour rendering will enable us to render this wireframe directly on top of the render. Unfortunately, it's not quite that simple. You need to decide which contours you want to draw. Now, in our case, it's around all poly faces. You can use around the silhouette, which will just put a line around kind of the silhouette of the object. You can do between coplanar faces, whatever you want. In our case, I'm just going to tick around all poly faces. Now, you might think that that would be done and you would render and it would work, but if you render now, nothing will happen. What you need to do is select the material that you want contour rendering to work with. So in our case, let's say Surface Shader 1, which is actually our light ambient occlusion shader. And then I need to go into its group. Now, if you can't find its group by going Material Attributes, if you don't see this SG shading group, you can always go into the Hypershade, select the light AO or whatever material you're working with, show its input and output connections, and you'll find its shading group here. Okay, so click on its shading group, come down to Mental Ray, actually click on its shading group, yeah, there we go, come down to Mental Ray and click Enable Contour Rendering, and this will allow you to actually control what color the wireframe you get out is. Now, looking at our render, we've got a fairly light object here, a fairly light ambient occlusion, so a white wireframe is probably not what we're looking for. So let's come up and make that grey. Now the width of the contour is a fairly important factor. Let me just render this at default, and you'll see I get rather thick, probably quite ugly, jagged lines. And I will say, while this is still rendering, when you render it in, you won't see the wireframe, you won't see the contour render. It's done as part of a post-production process. So if you hit render and you're not seeing it straight away, don't press escape, don't panic. It is going to happen. What will happen is the render will finish, and basically your computer will sit there for 30 seconds while the wire contour is calculated and then placed over the image. So if it doesn't look like it's working, you're going to have to wait for the render to finish and then give it a second or two, and you'll see it after that. Okay, so there you go. As I said, we've got this contour rendering happening now, but it's massively thick. But it does work as an illustration that this is actually only working around the one surface shader. It's not working in the background, and it's not working on here, because apart from turning on contours, let's have a look, in here, you also need to arm them for each individual material. Now this is a nice thing because it means that you don't have to display the wireframe over the whole object. In fact, if you look at one of my final renders, I've got wire here, here, and all the way up here, but this circle in the middle has actually got the wire view turned off. It's simply this material, but without contour rendering armed. So easy enough to do. If you want to exclude certain parts of the model that the wire would be distracting on, or it simply isn't necessary because pretty much anyone can work out what the wire on a sphere looks like. So no need to show it really. And I honestly thought it looked nicer in that particular shot. So now we've got this, and we've got these massively thick, very jagged wires. A couple of reasons for this. The main one being that the width is too high. Let's set this on 0.25 maybe. And if I render out again, you'll see once again this will come in a lot thinner, but it will still be pretty jagged. Okay, so now our wireframe is there, but look, it's missing parts and it's just terrible really. This is to do with the sampling that Mental Ray uses for these contours. Now by default it takes one sample really. We can oversample, which means it will render out the wireframe twice as big and then shrink it down to fit. So if I just do one oversample, so I'm stick the oversampling to 2 and get another render, I'll do a whole one, and I'll do this so you don't have to. Okay, so with an oversampling just set to 2, we start to get a much better wireframe on this. It's still a bit jagged, and it could definitely do with some smoothing out. So we can help that. We can turn the filter support up to 2, which will smooth it out a bit. And I'm going to crank the oversample, say up to 30. Now for a final shot, if time is not an issue, because at 30 it will probably take about a minute to calculate the contour, depending on how complicated it is, of course. So, if you want to spend an extra couple of minutes getting that nice final image, I've cranked this up to 60, 70, 80. Really it's down to you. At 30 should do a good enough job for what we need, and we see here this was 46 seconds. So I'll snapshot this. I'll do one last render for this process with this oversampling set much higher, so from 2 to 30, and you'll be able to judge for yourself when I flick backwards and forwards. Okay, so here's the new one with the filter turned up, which has made our lines blurrier, not so jagged, and with that oversampling, it's made more detail appear on these small wires here. So, again, it's entirely up to you, and actually it took around an extra 10, 11 seconds to do all the oversampling, so it's really not that bad. Now all you need to do is go in to your other surface shaders. So if we do material attributes on our dark AO, go into its shading group and enable contour rendering for that, width of 0.2, and I'm going to make these dark wires very dark because the object itself is quite dark, and we'll render out, and we'll end up with something that looks a little bit like this. Okay, so that's it from me really. I just wanted to do a brief demo of how I came from sort of this very bland render to this one that's, in my opinion, a little more interesting. And that was it. So if you have any questions, feel free to contact me, Dave at simplymaya.com, or you can always get us on the SimplyMaya forum. Plenty of helpful people there. So I hope you've enjoyed this one and taken something away from it. Thank you for watching, and hopefully I'll see you in the next tutorial. Bye.